Coffee!
Looks like Mommy's up. Better get her coffee.
Why don't you do it?
Because technically, I'm not insane.
So you would
Coffee!
expose your son to a woman who hasn't had her coffee yet?
And your point would be?
Fine, but if her coffee's too cold, you're cleaning the bloodstains off the rug.
Good point. I know. Wait until the very last second, then pour the milk in the coffee. It'll be fine.
No, you pour the milk in first and then the coffee, and then the coffee would be fine.
That sounds like a question for...
Oh no!
Mr. Science! Tra-la-la!
Isn't that a copyright violation or something? And by the way, nice lab coat, Dr. Geekazoid.
And now, to scientifically answer your question.
Coffee!
Can I please just get her a coffee?
Not until we've experimented. First, we'll pour 2 cups of coffee. Then, we'll add milk to one right away, and we'll label that A. Now, we'll wait 5 minutes, and then add milk to the second cup of coffee, labeled B, which will be hotter.
Scarlett Johansson?
Very funny, wise guy. But let's see what Einstein has to say about that. I've activated the experiment. Notice the blue line I haven't added the milk to yet. The red line, I've already added the milk. And notice how much the temperature is lowered. It's going lower and lower. Let's see. I think that means that I'm going to be right. Now I'm going to add milk to the other cup. Wow, look at that drop. Huh. Looks like you were right after all.
Well, there's a shocker.
So, what's the scientific explanation?
Don't know, don't care.
Well, I can explain, but it looks like we'll have to go into...
Oh no.
Animation mode!
Heat always moves from a warmer body to a cooler body. The heat keeps moving until the 2 bodies reach the same temperature. A body doesn't actually have to be a body. It can be any object or even an environment. In our experiment, the bodies are the cups of coffee and the air. Since the cups of coffee are hotter than the temperature in the room, the heat moves from the coffee to the air. Okay, I get it. Heat moves from warmer bodies to cooler bodies. That explains why the cups of coffee cooled off, but I still don't get why one cup of coffee cooled off before the other. When he wasn't coming up with the laws of motion, gravitation, and calculus, Isaac Newton described the law of cooling. The law of cooling states that the greater the difference in temperature between 2 bodies, the faster the heat will transfer. In the race to see which cup of coffee cools first, it's not just about the initial temperature, but more importantly, the difference between the initial temperature and the environment. The difference between the environment's temperature and the coffee without milk was greater than the difference between the environment and the coffee with milk. Therefore, the coffee without milk lost heat faster than the coffee with milk. And that's why it cooled off faster.
Coffee!
Can we please get her a coffee now?
Yes, absolutely. Just one problem. No more coffee.
Run! I hate science.